All right, here's questions 21 through 25 inclusively. So let's go over these EOC questions. All right, here's a line with a slope of -2 that passes through some point. Whoops, there you go. The line of some slope that passes through some point. Use the slope-intercept form. Slope-intercept form, where it's going to make your template. Y minus some number equals m times x minus some number. Right, those some numbers are your x and your y values from here. Stage your equation with negative signs. Right, your y from here is your 5, it goes right here. Your x from here is 11, it goes right there. Your slope is, this is slope, right, is -0.2 or a fifth. All right, so this is the equation, right? So it's asking me, hey, put it in, which one do I pick for each spot? So most of the work's already done, right? So y minus 5, okay, equals -0.2. This is the first one. This is the second fill-in. The third fill-in is x minus 11. That's my third fill-in. That's my third fill-in. So it's already there for you. Okay, that one's pretty easy. Okay, here is an expression, and I have to write this as an equivalent expression. Okay, so remember that this 2 is individually the dividend, or the divisor, excuse me, the divisor of 3 different terms of the numerator. That was hard to say. All right, so I can break this down into 4x squared divided by 2x minus 18x divided by 2x plus 6 divided by 2x. And from there, I can reduce each one of these, or I can simplify each one of these. All right, I have an x on the bottom, 2x on the top. That one wins as x to the first. 4 divided by 2 is 2x over 1, right? It's just 2x. That turns into a 1, right? So that's just going to be 2x. Right, and then I have negative 18 divided by 2 is 6. X to the first is cancel out, so it's just going to be minus 6 over 1, which is minus 6. Right, and then I have an x on the bottom here, right? So this term is 6 divided by 2, which is 3 divided by x, or this could be 3 times x to the -1. So it's going to be plus 3 over x, or it's going to be 2x minus 6 plus 3 to the x minus 1. Right, so let's see which one exists. Right, so the 2x is this one, and that's it. All right, so, oh wait, this was 18 divided by 2 is not 6, it's 9. Sorry about that, 9. See, even if you make a simple math error, you can still pick out the answer pretty easily. So minus 9x plus 3 is A, right? So you can cancel this out using any type of term. Right, here's an equation. This is a vertex form of a quadratic. So what type of function is this? Oh, it's quadratic. So the vertex is at 3 and 1, because this is the opposite x value of your vertex, because that negative sign, and this is the y value of your vertex. And the A, this is concave up, right? Because y equals a times x minus h squared plus k, where this is how it's stretched. If it's negative, if a is positive, it's concave up. If a is negative, it's concave down, right? So right here it's positive, they just don't show the positive. So that was that one, that was super easy. Okay, here's a given function, and now it says to evaluate h of 15. when h of x is 1/5 x squared. So this thing is saying, hey, everywhere you see an x, right? Everywhere you see an x, you plug in 15. So h of 15 equals 1/5 times the quantity of 15 squared, right? And then PEMDAS tells me to do, please excuse my dear Aunt Sally, or pulsating electromagnets destroy alien spacecraft. So it's going to be, I have to square 15 first, because nothing inside the parentheses to like simplify. And next I do the exponents. So I have to raise 15 to the exponent, and then multiply by 1/5 or divide by 5. Either one is that. So multiplying by 1/5, nope, don't do that first. Multiplying the square of 1/5, no, that's not right. Multiplying 1/5 by the square of 15, then dividing by 15, no, that's not right. Multiply the square of 1/5, then divide by the 15, then dividing by 5. Hold on, let me read this. Multiply 1/5 by the square. That first one's right. It does it differently, right? So I'm gonna square 15 and then multiply it by 1/5. That is the correct answer. Okay, I don't have to do anything more crazy with the 15s. All right, that's 24. Last one's 25. All right, so I have categorical data here. It says, hey, categorical data, because there's no numbers in here. 11th and 12th graders are not numbers, they're categories, right? And then this is the percentage of people who like to either bus, car, or walk, right? So this is categorical as well, right? So this is a categorical, right? And then remember, a percentage is not a variable, okay? Percentage, well, it is a variable, but it's just the number of people of the set. It's the percentage of the set, right? So I'm not really comparing the percentage to another number. I'm comparing the percentage to a category, right? So there's only one variable, right? And it's a univariate, right? And then this becomes categorical. So this is univariate and categorical. All right. That's all of them. I hope that works and it makes sense to you guys.